Question number 9 of 10D. A 4-digit number with no repetitions, meaning once a number is chosen, it can't be used again. It's to be formed from a set of digits. So you're given 8 numbers in total, 0 to 7. Find the probability that the number is even or is odd. So as you can see, if the number is even, then it's not odd. So there are only 2 choices. So all the probability of being even plus the probability of being odd will be 100%, because the number is either even or odd. This question could be solved in 2 ways. I'll introduce the first one. I think I already posted a slide with a slightly faster method, but okay, I'll explain the difference between the 2. So let's say if I'm trying to find the probability that the number is even. First of all, I have to identify what are the total possibilities. Okay, so you have to choose 4 digits from these 8 digits. But the first number cannot be 0, right? So which means anything but 0, so you're left with only 7 choices for the first digit. So 7. So this number is not 6, it's still 7. Why? Because these digits, you have taken 1 already. However, for the second digit, 0 can be a possibility, right? It doesn't matter for the second digit to be 0. So therefore, you lost 1, you gain 1. So it's still 7. Then 6, and 5. So the total sample size will be 1470. And then what is the sample size for even number? So for a number to be even, only the last digit matters, which means it's either 0, 2, 4, or 6. These 4 choices. So 4 is here, because you have only these 4 choices. So among the 8 numbers, the total possibility for the last digit is 4. So you've taken 1 already. So among the 8 numbers, you've lost 1. 7 left. Then 6, then 5. Some of you may think, why the first number isn't 6? Because it can't be 0, right? You can't put 6 because there is a chance that you may choose 0 for your last digit. So which means when you have chosen 0 to be your last digit, then you have taken out this possibility. Then that left you 7 choices instead of 6 choices. You can't just say that because 0 can't be the first number, so 1 taken already, then 0 can't be used, so I left 6. No, you can't say like that. Because there's a chance that you could still choose 0 here, and then you left 7. So I have to do it in this way, that I just assume 0 can be used first. So which means once you have chosen a number for this, you left 7, then 6, and 5. Then I minus away those numbers, those even numbers that 0 is chosen for the first. So let's say, okay, so if let's say 0 is chosen over here, so it's 1 possibility, right? 1. And for the last digit, 2, 4, 6, you left the 2, 4, 6 because 0 is chosen already, so 3. So taken 1, you're left with 6, then 5. So therefore, the total sample size for 4 digits, even number, is this one, 7 times 6 times 5 times 4, minus 1 times 6 times 5 times 3, which is 750. And the probability is 750 over the total sample size, 1470. So this is a probability of even number. So for the odd number is 1 minus this value. Okay, so actually with this you solve both A and B. Or you can solve the other way. which is what I introduced earlier on in the slides. So for odd number, the last digits, what are the choices you have? It is either 1, 3, 5, or 7. So there are 4 of them. And 0 is not among them, right? So which means I can exclude 0. So if I exclude 0, and then here has taken 1 digit, how many do I left? I left with 6. So in this case, I can put 6 instead of 7. So 6 then. Why is it still 6? Because 0 can be included over here. So I lost 1 more digit, but I gained 0 as a possibility. So 6, then 5. So this will be the sample size for odd number, which is 720. Then you divide by the total sample size, 1470, you get the probability. So this is the probability of odd number. So for even number is 1 minus this value. So either way you can solve A and B at the same time. Okay, C. C is actually much more straightforward. So it says that is less than 4,000. The probability that this number is less than 4,000. So only 1 digit matters here. Which digit? The first digit. The rest doesn't matter. So only the first digit matters, so which means it must be smaller than 4,000, meaning only 1, 2, 3 can be chosen, right? Only 1, 2, 3 can be chosen among these 7 numbers because 0 can be the first digit. So 3 out of 7, the probability is 3%.